guess. All right. Well, thanks to Jorge and the organizers for inviting me to come speak here with you guys. We're going to talk about data science projects in professional sports, although basically data science projects with the Florida Panthers organization, but I can talk a little bit about other sports. I guess a little background since the organizers kind of mentioned that some of you might be interested in the background. So I was an electrical engineering major at Lafayette College. I went to grad school for math. It was like pretty theoretical math at Johns Hopkins. After that, I was a professor at the United States Military Academy at West Point, and I taught math and stats there. And during that time, I kind of my main area of focus was data analysis for hockey, basically. And so it was at West Point that I got in touch with the new ownership group with the Panthers. One of the owners of the Panthers happens to be a West Point graduate, so sort of through a friend of a friend of a friend, I got in touch with the organization. Eventually moved down to Florida in summer of 2014, and I've been here about 4 years doing data analysis for the Panthers on the hockey side. So I started on the hockey side of things with players and teams. More recently, I've been working on problems on the business side of the organization, sales, marketing, finance, things like that. That's what I'll probably spend more of the time on today, but I'll also talk about some of the hockey stuff that I used to be doing. So, please interrupt with like questions at any time. I like interactive classrooms, so I'm going to pretend this is a classroom. Okay, so interrupt anytime. If you're live tweeting, here's my Twitter account right here. Twitter, LinkedIn, and Gmail, they're all BMAC NHL. So feel free to reach out to me after this also, if you'd like. I'm kidding about live tweeting. I don't think anyone's live tweeting this, but no one laughed, so I figured I'd point out that was sort of a joke. But maybe someone is. I don't know. I have friends that live tweet everything that they're ever at. So I thought I'd start. Well, you know what? Let's start here. So here's one of the problems that we worked on recently. We started last spring actually, and it started as a project with University of Miami students. It was one of the capstone projects for the students who are in this program. So if you think this project is cool, think about the program. Maybe you'll be able to do something like this. But what we wanted to do was we had a bunch of data about our customers. And we have a bunch of address data, we have a bunch of location data, and we never put it on a map. Like the most that we would do with location was create a table that computes a bunch of things by zip code or something like that, and that would just be just a regular table in Excel or something that lists zip codes and a bunch of information, a bunch of data for those zip codes, but you lose all the spatial information if you just look at a table of zip codes, like what zip codes are near which other ones, how is there any sort of relationship. So we set out to start to plot some of that stuff. And we also wanted to plot some other information. So we wanted to know, so we don't have demographic information about all of our customers, but the census has demographic information about every little region in the area. So we wanted to plot our own data, we wanted to plot census data, we wanted to plot driving time data, driving time to the arena data, especially for weeknights. Games that are on weekdays as opposed to games that are on weekends where there's evening rush hour. And so this is some of the stuff that we see here. So this slide comes from the US Census. So here we have in this map, so this doesn't work, so I guess that's the point. Yeah, you can't see that, that's funny. Anyway, that's our arena. So here's Fort Lauderdale, Miami, Boca, West Palm up there somewhere. Here's 595 right here, just to get your bearings. And so this map is colored by the percent of people who on the census for the ethnicity question or for the race question checked white. And then for this one, they checked Hispanic. Or for this one, they checked black. For this one, they checked something other than those three. So I guess this maybe doesn't tell you anything that's super surprising. There's there's a larger white population up here, a larger Hispanic population down there. That's probably sort of something that we expected. I didn't expect the difference to be this great, but maybe that's because I don't know the area too well. I don't know. I didn't spend much time in Miami and didn't spend a whole lot of time up here. I guess where I am, it's a little more mixed, but that was pretty interesting. The difference. I mean, you kind of know there's a difference, but kind of nice to see it on a map also, I guess. And it's nice to see it alongside of other things also. So this came from the U.S. Census, and other things that we could look at are age. They have median income, they have median housing value, they have median number of children, or maybe mean number of children. Things like this. So anything that the census has, you can plot it something like this on a map of South Florida. So we plotted a few more things. One of them was driving time. I might have said driving distance before. We wanted driving time to the arena. We didn't want like straight line distance. We didn't even want distance traveled along roads. We wanted actual time to the arena because especially in evening rush hour traffic, certain places it's going to be really tough to get to the arena because of traffic, and certain other places it won't be as tough, and it will depend somewhat on distance, but it won't totally depend on distance.
I was going to say you want to measure pain is what you
Yeah.
How did you calculate this?
So driving time, we used estimated driving time from Google Maps from each of these. So these little blocks that you see here, these are all census blocks. So everything that we've done, the census data was in census blocks. So we wanted to use census blocks for everything else, for our own data, for the driving time data. So we picked in order to do this, we picked the middle. We found the centroid of each of these polygons, each of these census blocks. We just found the middle point according to some definition of middle. And we plugged that into, we used there's an API for Google Maps that tells you driving time, and you can specify, if you go to maps.google.com, you can put in directions, but you can also specify an arrival time or a departure time. We specified an arrival time of 7:15. Our weeknight games start at 7:30. So we specified an arrival time of 7:15 on like some random Tuesday. And so it gives you an estimated driving time during that time of day. And so that's what we used to do this. So it was kind of like once you wrote the code, it was automatic. I think they started plugging these in, finding the centroid by hand and then plugging them in or something, but then they wrote some code, the students wrote some code to do it automatically. So it's basically coming from Google Maps using their API. And so it's colors, obviously yellow is closer to the arena, blue is really far away. And it's kind of interesting because you can kind of see it's not totally straight line distance or distance traveled along roads. You can definitely see a difference along the highways. The yellow definitely extends more along the highways, more along there, and even up here it extends along there a little bit more than it does, along some of these back roads this way. So this is much further away than that, but because our metric is time, not distance, this one is a little bit of a lighter color than that right there. So it's not exactly like a circular radius around our arena here. There's definitely, some sort of shape like that where the yellow is extending further out along the highways. So this one is age. This is from the census. Darker is older. I think it's median age, or it might be mean age. My mom lives right there, so it seems to be accurate data. But there's definitely pockets. I mean, I know that's a retirement community. That's a retirement community. I assume this. I've never been up there, but I assume that's a huge retirement community. This is median household value, median income, and this is median household value. Those look almost the same, except, what do you notice? This is the interactive portion. The first interactive portion. What's the difference between those two?
Fort Lauderdale seems to have inflated value as compared to the income.
Okay, so around here?
Yeah. Maybe a little bit more than some other places.
Yeah. Even all along the coast here seems to be higher than along here. And maybe that's because there's a lot of, I don't know the exact reason, but maybe it's because there's a bunch of folks who are retired, have expensive houses, but don't have a very high income.
There's a bunch of high-rises along the coast, so the property values are cumulative.
Yeah, that's true. Yeah, yeah.
I'm curious as to I can see diving into analytics on income, right? More income, maybe more likely to buy a game, more likely to buy ancillary products or so on. But I'm curious as to why the household value. Do you have any context on that, or is it a proxy?
I think we just wanted a proxy for.
Why is the value higher?
No, just why collect that data to begin with? I can see why they collect data on age and drive time.
Well, because I'd say from being up north in hockey, it's it costs money to play hockey, and it's
right. But if they already have the income, why grab this second ancillary measure?
So I think the reason is probably folks along the coast might not have a lot of income because they're retired, but they might have a lot of disposable dollars to spend. So this could be a proxy. These two combined could be a proxy for disposable income. How much money they have to spend
maybe
on
be a more
recreation
measure.
Yeah.
Okay, cool.
We haven't actually used either of those in a model yet, but we should be within the next week, hopefully. But part of the point of this is to make cool, pretty pictures. But really, the real reason is we want to use this somehow to understand our customers, or for example, for lead scores. So that's what one of the student groups is working on right now, is lead scores for us, where they'll be using a lot of this information that we're talking about here as part of the model that basically some sort of predictive model that is giving you some sort of indication of how likely this customer might be to buy season tickets or single game tickets or whatever.
Hey Brian, how many data points are you guys using for that prediction?
Well, I guess eventually we'll use all customers, for example, that have purchased a ticket for any game in the past 4 years. So I think that might be 70,000 different people have purchased tickets, something like that. If I remember correctly, 77,000. So not huge, but not small, I guess. Medium data. It's a medium data problem.
One quick clarification on the data. They do the census every 10 years, and then they do an American Community Survey every year, I think. So yeah. I'm assuming this is from the latest one of those.
Yeah, good point. So this is from 2015, which I guess they do I don't know if it's the American the community survey or whatever, but it's some sort of lesser than full-scale census. So. It was the most recent one that we could find, pretty decent information for. So we'll probably, update this after 2020. Okay.
From you being at the state, the stadium, where do you think, if they were to build a new stadium, from what you know, would be the optimal place?
That's a good question. That's a pretty good pretty good data analysis question also.
Right.
My guess would be,
Because I have my theory. I just wanted to.
my guess would be not down here.
Not down there.
Yeah, not down
Right,
here.
exactly.
But my guess would be like Fort Lauderdale, downtown somewhere.
'Cause
You're maximizing distance from people over here.
you want to be able to hit West Palm too, though. Right?
Yeah.
Yeah.
And we do get fans from West Palm, but
More towards the water.
You're really you literally are maximizing your distance away from people, like
Right.
it being over here. The land was cheaper, and it's actually easy to get in and out,
Yeah.
and traffic usually isn't terrible around the arena, so those are good
Yeah.
things. But it's it would
Trade-off.
probably be nicer to be somewhere downtown or
Yeah.
somewhere
Right
near
here.
595, the Turnpike, and 95, like this area.
Yeah.
If not downtown, then like this area,
Yeah.
somewhere around there is my guess. But that is a good data analysis problem
Yeah.
because you have a bunch of information about customers. I mean, if you look at, there's certainly like more money around here, so maybe that would
Right, because
factor
I
into
look at
it.
like who plays hockey, and it's like usually it's the people that have money, it's the white people that have money, their kids. So if you go down too south, you're chopping off more people with income up north with the West Palm and the so you want to be like percentage wise, we get a lot of people from up there. I'm just speculating.
Yeah. Yeah, and I think one of the reasons they moved up here, well, first of all, the land was cheaper here than here.
Right.
But one of the reasons they moved out of Miami is because most of the people who move down from the Northeast or who are snowbirds, who temporarily relocate from the Northeast, they live in Broward and near West Palm or Broward County or whatever. So they live up in that area. So for sure, like demographics played some sort of role back then when they decided to move the team out of Miami. And I'm sure that'll play a role again if they're ever going to. I mean, well, they'll eventually need a new arena, but if they ever decide to move the arena or whatever, I'm sure they'll. That'll play a factor again. I don't see them going back to Miami, for example.
Yeah.
All right, so then we wanted to plot some of our customer data on these maps also. So we could do this in various ways, but let's plot a scatter plot of the location of our full season ticket holders on this map right here. And there we have it. And a large majority of our season ticket holders, I mean, this isn't surprising at all, but a large majority of the season ticket holders are in the yellow region. And they even extend out on the yellow region, like along the highways. So it really seems like driving time matters. If you're going to be a season ticket holder, you're probably not living an hour away. I mean, you're less likely to be a season ticket holder if you're living an hour away than if you live 10 minutes from the arena.
I like the
So-
ones that are out in the ocean.
For sure. What's that?
I like the ones that are out in the ocean.
Oh yeah. So there's a little bit of jitter added. So that means that's why those are out in the ocean. And I think some are in the Everglades. I wouldn't recommend actually living there, but you never know. Yeah, it could be actual Florida Panthers that are season ticket holders.
Do you guys use R for all these visualizations?
Yeah, this is all R. Yeah. Yeah, the package for the maps is called Leaflet. And then, the students made an interactive web app, and that was using the package Shiny. So they used both of those in conjunction. I'm just showing screenshots from that web app, but yeah, it's pretty good. I mean, you can't tell here, but you can zoom in and out and pan and zoom just like you can if you're on Google Maps. So it works the same way.
So out of curiosity here, because is the map itself like called from a Google Maps API, or is it something that's or I guess maybe that's a
OpenStreetMap.
It is
Oh,
OpenStreetMaps. Yep.
Okay.
I guess you can't see. Let's see. Well, yeah, I don't know. Let's.
yeah. I was gonna make that makes sense because the legend doesn't look the same. It looks like they have
They're
different.
just getting the drive time data from.
How do I get rid of? Oh, there we go. Oh. There. Yeah, OpenStreetMap.
Okay.
Yeah.
Cool.
Yeah, I should get rid of these NAs, but I think these are census blocks that there was 0 people in or something like that. Or maybe there's only 10 people and there's no median income reported for that census block or something like that. So one of the, so I mentioned like the main reason for doing this was, for like marketing and like lead scoring type problems. So we want to know which customers are most likely to be interested in buying season tickets. We want to understand our customers better. So that was our main reason for this, but actually the first thing that we used this for was coming up with recommended billboard locations. So we had a bunch of possible billboard locations. Where do we want to put the billboards? And so collecting data about how many people see billboards is sort of challenging. Maybe if you can do some really good eye tracking with some really high definition cameras that you secretly place on a billboard pointing down towards the road, maybe you can do something. So, but we had to figure out another way. How could we come up with like a proxy for how much exposure a billboard would have? And so we wanted a, marketing department kind of told us like certain things. They want them sort of spread out, hitting a lot of different regions. They wanted them to be near higher income areas. What else? And high traffic areas, obviously. But here, when we started thinking about, we wanted to determine the locations that would yield the best ROI. So we have the cost of the different billboards. So the company charges different amounts for different billboards. Who knows how they come up with it, but I'm sure it has something to do with how many, how many cars they suspect pass by that every day. I think they had some sort of estimate of like eyes, sets of eyes of people over the age of 18 who see this on a daily basis or some metric. I have no idea how they come up with that. And we wanted to come up with our own way of determining how many eyes see this or what is the exposure of this billboard. And we wanted to maximize something like exposure per dollar or something like that. So, yeah.
What was the goal? Like attracting new clients,
Yeah. So,
or trying to keep track with the former clients and say, yeah, we're gonna have our next game.
yeah, I would say that was not very well defined. So we just did, I don't know, it's probably a combination of both, but I don't think it was well defined. I think it's more attracting new customers for like single game tickets than it is for attracting full season ticket holders. But at the time when we did this, I don't think we were to the point where we had a very well-defined problem statement like that.
So if you put the billboards on the highway, right? Say like, for example, there's like 20 billboards stacked on top of each other. Boom, 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 boom. All right, say you could afford, and your budget is 5 billboards. What would be the optimal way? Just to blast people, 5 in a row? Or to space it out, every 4?
So I don't know about that 5 in a row if they're within like a few hundred feet of each
Because
other.
then
We weren't considering
Yeah.
that case, I don't think. I'll show you the candidate billboards in a second, but they're pretty spread out, so that situation didn't come up. But it's a good question. I mean, maybe seeing 5 in a row, it would catch your eye because out of the corner of your eye you see some sort of repeated pattern that makes you look there.
Driving in places, and that was their strategy, and it was like they just bought every billboard for like the last half mile.
Yeah.
Under the border.
Yeah.
But
Taco says.
and that's kind of like an interesting question in its own right. Does like you said, I can imagine it being something of a bit polarizing. Those that weren't gonna buy it, they don't gain the extra value from the exposure. Those that are gonna buy it, each time there's an incremental amount of extra exposure. Mm-hmm. The question is that incremental amount good enough to justify buying multiple?
Right, exactly.
That is interesting. Good thought.
Okay, So we didn't want to base the decision on number of cars. We wanted to base it on some estimate of exposure time to the billboard. So for example, the areas where there's more traffic during rush hour, you might have more exposure time to that billboard because you're driving slower. And so we wanted to come up with an estimate for that. So we wanted average exposure time per car times number of cars. And the way I wrote this, every time I look at it, I'm like, why did I write it like this? Because it looks like you can cancel cars and exposure equals average exposure time. But that's the idea. Like, what's the average exposure time per car plus the times the number of cars? And so we got, we had the latitude, longitude coordinates of all the billboards and also which direction they're facing, northbound, southbound, eastbound, westbound, whatever. We had the cost. We got average daily traffic from Florida Department of Transportation. Their website, I think we just got it from their website. It's freely available. And then we went to Google Maps to determine average driving speed near the billboards during morning and evening rush hour. So we literally zoomed in and picked like 2 points near the billboards, determined the time that it would take from point A to point B, and something like that to determine average speed. And I don't know why I put that picture there, but here are the billboards, and this is just a zoomed in version of this area right here. But here are the billboard candidates. The ones that circled in green were the ones that we recommended because these had, the dots are also colored by return on investment, basically. So exposure hours per dollar. So we want to maximize exposure hours per dollar. So that's what the dots are colored by. The inside of the dots are colored by. So that one's dark, that's dark. These are all dark around here. The green outer edge is the ones that we recommended just because of combination of exposure hours, maybe where they're located. I think we wanted ones near higher median income areas. I think this one was this is median income, I think. So we had some up here. We wanted them to be spread out. We didn't want all in here or anything like that. So we spread some of them out and tried to base it on things that sort of made sense. The best that we could do with like limited data, a bunch of like guessing, a bunch of assumptions and things like that was sort of the best you can do without doing really advanced eye tracking like I described before, which is probably impossible at this point. Maybe the government does it or something, I don't know, but
yeah. Quick question, because that's an interesting point that you made about maybe recommending the ones that are maybe a little bit spread out from each other, but also near higher income areas. And again, maybe the specifics of this is a little bit maybe something that can't be shared so much, but I was wondering, was there some part of your model that automatically accounted for median income, or was it that you saw the billboards, you saw the average exposure time, and then you said, oh, let's look at the ones, because I was thinking maybe this is a weird measure, but you have average exposure time, and then you can almost like say like average exposure time that accounts for income dollars. I don't know if it'd be linear where you say, oh, getting the eyeballs of a $40,000 income is only half as valuable as getting the eyeballs of $80,000 income.
We thought about doing something like that, but in the end,
it's a weird measure.
I think I don't remember why we didn't do it. It might have just been we ran out of time or something.
Mm-hmm.
So we came up with our exposure per dollar, plotted on here, and kind of eyeballed it from there.
Cool.
So maybe not the most rigorous thing, but that's kind of what we did. But yeah, I mean, ideally your algorithm would take into all those things, the lead scores that we're coming up with now, it should take into account that. That's exactly what it should take into account of, actually. And then you might want to have them spread out using some algorithm that tends to want to suggest billboards that are spreading far from each other. So like repelling the number of, there's
like
some sort of like electrons repelling,
Yeah, or like a K-means or something like that, where they're clustered into regions, and you say, let me grab 2 billboards per region.
Yeah, something like that.
Mhm.
Yep.
Do you have more details on the yellow dots?
The green dots?
The yellow dots. The ones, no, in the big map you have some items, some billboards on 595,
Here?
a little bit to the left.
Here?
Yes.
Oh, I think they were just really expensive, and there tends to not be a lot of traffic there. Whereas these are all high because there's tons of traffic there. It takes forever to drive in these areas of the highway during rush hour. There's usually not as many. There's not as many traffic jams here. There's always tons here. I think that's why they're much lighter color. They were probably expensive and not as high of exposure hours as the other ones.
How you guys were planning to validate the ROI?
I don't think there is any way, unfortunately, because we don't know how many people have seen them. We don't know how many exposure hours. I mean, I don't think there's any way to do it. I mean, the only things we thought of is you could include a promotional code on the billboard. And if the number of people that use that, you can assume that they saw the billboard or something like that. If you give each billboard a unique promotional code, but
But that code has to be short enough
Yeah.
to remember.
Yeah,
Like, if
yeah,
you
exactly,
10
yeah.
code, 10
That's
digit
the
codes.
problem.
and then
Remember
they forgot.
promotion code B.
yeah.
So the billboard, what information was there? Like a phone number, website? What type of?
It's usually like the website on there. There might be the phone number also, or it might just say Florida Panthers.
The person, whoever the form you were filling, you could have like source of how do you find out about us, and include like billboard or.
Yeah, that's true. So we could survey people. That would be another way to know that. But survey responses tend to be, like 10% of people or something will actually respond. So, yeah. Question?
How long was the billboards up?
I think it sort of varied. I don't know how many hours or how many days. I don't even know how they compute the exposure, because I think they're all digital billboards. I could be wrong about that, actually. I think there's some paper billboards, because I remember we ended up this year. Yeah, we started it in the fall, and we waited until after the hurricane to put any billboards up. And I don't know if you noticed, after the hurricane, it seemed like every billboard was like torn to shreds. So it's a good thing we waited, I guess, until after the hurricane. So I think I'll skip this in the interest of time, and we're going to go to another project that we worked on. And some of you who were at the data science salon might find this to be boring, because this is the same thing I talked about there. But maybe it'll be more exciting the second time around than the first time. I don't know. But oops, that didn't show up over here. Why not? Wait, you're still not seeing that. Why? I'm going to duplicate that. Okay. So here's a separate project. Well, any more questions about the other one before I move on? All right. So here's another problem. So we set out to develop a model for predicting attendance for games, for regular season games at our arena, using only information known before tickets go on sale. And the reason that we wanted to do that was, there was a couple reasons. One of them was for deciding which games should be in which tiers for variable pricing. So not all our games are priced the same. To give an example of like the Miami Heat, which is closer to here, if the Cavaliers are in town, the ticket prices are probably higher than if, pick your favorite worst NBA team that no one cares about. I don't know. Usually when I give the Dolphins example, it's if the Patriots are in town, the prices are higher than if pick your. See, everyone always says Browns. So
Loaded question.
that's the first time anyone's not said Browns. The first, like Buffalo. Buffalo was the first answer, but eventually everyone always says Browns. So for us, Montreal Canadiens between Christmas and New Year's is always our most popular game, and that's there's a lot of people from Canada who come down over the winter holidays to vacation. There's also a large French Canadian community, I guess, north of Miami somewhere, and they're in our division. So for a lot of different reasons, that's our most popular game every year. So that's more, that's definitely going to be a higher price than some game in October, again on a Tuesday night against some Western Conference team. So which games should be in which tiers for variable pricing? What kinds of things could we request when the league is developing the schedule? So one of the specific questions that we were asked to try to answer is, do we want a good team on a Saturday and a bad team on a Tuesday? And by good and bad, I don't mean like they're good in the standings.
Right.
I just mean good drawing team and a bad drawing team, like popular or unpopular. So we want good teams on Saturday, which is usually the best day for a game, and a bad team during the week, or a good team during the week and a bad team on Saturday. In other words, do we want to stack all the good teams on Saturdays, or do we want to kind of spread things out a little bit? And so one of the first things that we did, besides getting the data, cleaning the data, organizing it, merging it with other data sets, which I'm not going to talk about because it's boring. I'll skip right to the visualization part because that's not boring. So we plotted some data. So we plotted attendance by game for 10 seasons for all 30 teams. All 30 teams before this year. Now there's 31 if there's any hockey fans that think I'm misspeaking right now. There's 31 teams now. When we did this, there was 30 teams. Okay. I guess I could add the 31st team now since the regular season's over, but. And I should note that we're plotting attendance by game, but it's announced attendance. It's not true people in the building. It's not true number of tickets sold, because we don't have that information. That's not publicly available for all teams. We have that for ourselves, but that's not publicly available for all teams. What's available is announced attendance, which is usually some sort of combination of tickets sold, whether or not they show up, complimentary tickets given out, whether or not they show up, and then it's usually something like that. And some teams,
So it's inflated.
some teams may or may not inflate or deflate the numbers at their whim.
Well, how much do you guys inflate?
What's that?
How much do you inflate?
I don't do anything to the numbers. I present the numbers. I am an analyst, so.
Because everybody pays for
So that's one thing. I mean, and also, like, do you count standing room only tickets or not in your attendance? I mean, people might have different ways of computing announced attendance, but for the most part, it's something close to paid tickets, whether or not they show up, comp tickets, whether or not they show up. If you hand out 3,000 comp tickets and only 1,000 show up, maybe you don't count all 3,000 of those. But it's something like that. Yeah.
Quick question, like 2 or 3 sentences ago, you said something about standing room only. I'm unfamiliar with that. What does that mean?
It's just you don't when you buy a ticket, you don't get a seat. You just get a place to stand somewhere.
Okay, got it.
Yeah.
So it may or may not be limited by the stadium seating.
Right.
Okay.
Yeah. So we'll see in a second that some teams appear to go over capacity, more than 100%, and in fact, they report their attendance as being 103% of capacity, which is it makes me explode on the inside because that is impossible. But
Is hockey attendance any different for any other sport, like baseball or basketball, in terms of attendance, all of that?
I would say it's like similar to basketball, like as far as number of people that go per game.
Right.
Yeah, I would say it's similar to basketball. The arena sizes are roughly roughly the same, and the same number of games per season. So I would say it's similar to basketball. Okay, so here's a plot that I just described, and it's sort of a mess, not a mess, but it's sort of a lot to take in. So let's focus on the lower left-hand corner here. And let's talk about this a little bit. Along the bottom is time, so this is date of the game. Along here is announced attendance, and each dot represents a home game at this team's arena. So this particular dot right here happened sometime right before January 1st, 2010, so probably like December or November of 2009. There's roughly 14,000 in announced attendance, and it was at St. Louis's arena. So here comes the second interactive, well, this has been a lot of interactive, but here comes the second time where I force you to be interactive, and I ask, what can you tell me about the data? This is a pretty simple visualization. All it is date, announced attendance, and a bunch of dots for every game. But what can you tell me about the data by just looking at this visualization?
From my viewpoint, I can see the New York Rangers have a very stable attendance.
Okay,
across
so
all
the
time.
New York Rangers have stable attendance.
Yeah.
It's selling out.
I assume because they're selling out every single game.
Yeah, that's my team.
Okay, all right.
One day they don't sell out, and I wondered what game that was.
Yeah, this one right here.
Yeah, that was
Any
like a
ideas?
really bad game.
Any
Or maybe it
ideas?
was during the hurricane.
Superstorm.
Close. A cold version of a hurricane.
Yeah.
Sandy.
So it was a blizzard.
Okay.
Yeah. And the way I realized that some of these there was a bunch of games with blizzards is first time through the model I did at the end I checked the games that our predictions were off the most.
Yeah.
So the biggest errors. All the biggest errors were we over predicted. And like 6 of the top 7 were all weather related actually. And the reason I realized it was weather related is like the second and the third one were both in the New York area on the same date. It was like Jersey and it might have been this game. It was Jersey and the Rangers or something. Both had terrible attendance for some reason on the same date. So then I Googled the date, and the first link was the blizzard of blah. So, all right, what else?
So you have stable attendance in all the other 3 sections, but New York I has some issues with attendance.
Yeah, so New York Islanders, so they're also a hockey team in New York. They seem to have highly variable attendance. So, you know, I mean, there's a bunch of reasons for that, I think. One, there's a bunch of reasons for the difference between this and this. Number one, the Rangers lately have been pretty good until this year. They were, you know, probably in the playoffs almost every year there. They're in Manhattan, in Madison Square Garden, so like downtown Manhattan, right smack dab in the middle of everything. Whereas the Islanders weren't so good, although they've been better recently, but they weren't so good back here. They were in Long Island for a lot of the time, so not really Center City or anything like that. They're on Long Island until here they started playing games in Brooklyn. The New York Rangers are one of the original 6 teams in the NHL, so they've been around much longer than the Islanders, so they have an older fan base and just a wider fan base in general. Those are a few reasons why maybe the attendance is more stable and constant sellouts at the Rangers.
I can tell you maximum capacity. I can tell you the range, average, means.
Yep.
All from those pictures.
Yep. You notice that everyone has a different capacity.
And also Tampa Bay, it looked like recently Tampa Bay had stable attendance. I think that's maybe it's, recently they were very well, Tampa Bay.
Seems like this is going
since
up.
2012.
Yeah.
And
I think around this time is when they made like the Eastern Conference Finals this year maybe, or maybe the year before. They made the finals, I think here. One of these two.
Yeah.
I forget now, but
one or more.
and And then, they're one of the best teams this year also. So I'm sure if we show this year's attendance, it's sellout also. But yeah, so winning seems to matter, and we'll see that when we look at all 30 teams again. That winning seems to have an effect on attendance, which is not surprising
So it's
at all,
who's
especially in South Florida.
Like, who's your star? There's always like one or two good players that just basically carry the teams.
Yep.
Yeah. So.
Yeah, that could be too, like star
Yeah,
power.
or
It could be
they're
winning, it could be star power.
Yeah.
Yeah.
Quick question. I'm not sure if this is actually significant enough, and it's just a tiny thing that I'm noticing here. It seems that this gap between 2012 and 2013, it looks like the off-season gap was a little bit bigger than the other seasons.
It
What
was.
was the reasoning for that?
There was a lockout for the first half of that season. So there were only 48 games that year instead of 82.
Okay.
And so that's what he's talking about is this is much narrower than that and that. And this was the year of the lockout. That one is much narrower.
So, from that data, can you tell, like, for the low point on Steelers, 2016 game, do you know who they play against? And this all tells me about the New York Rangers.
That's St. Louis, maybe.
St. Louis, sorry.
St. Louis? Oh.
So, do you know what's the low point who they're playing against?
So we know their opponent in every game. Yeah, it's not, you can't tell from here, but we do have the home team and the away team. So away team, you can't tell from this picture, but away team does affect attendance, and we'll see that in a second. Anything else you learned from this?
Do you guys try to emulate or associate yourself, the Panthers, do they associate themselves with the Lightning, since they're both Sunshine State teams?
I guess
Do
we
you guys
kind of root
use,
for
like,
them.
The same marketing type or?
Yeah, I
some
mean,
type of analytics?
there's definitely similarities between the two, and I think, it's nice to see when they're doing well, it's nice to see hockey in Florida doing well, and so in that sense, yeah. We don't really have a rivalry with them yet. Hopefully we will, but we've never actually met in the playoffs before. In fact, we've never been in the playoffs the same year before. It almost happened this year. We were like one game away from making the playoffs, and we probably would have faced them in the first round. So it almost happened this year, but we just missed the playoffs. So we don't have a rivalry yet. So there's not really. I don't think we
As
hate
far
them or
as-
they hate us. I mean,
Yeah.
yeah.
As far as trying to attract customers that are in the Sunshine State. way-
I think we don't have overlapping markets really. Like maybe in Fort Myers area is maybe halfway between. Maybe people have to decide between the two or something. But separate markets. We probably try to attract fans in similar ways.
All
But
the winter
we're usually not
birds.
competing for the same fans. Yeah. What's that?
Because all the winter birds, they either go to Naples, Tampa, Miami.
Yep. Yep.
So they probably do the same thing. Like during the winter, they would do the same thing, try to attract Canadian fans.
Yeah. Yeah. And like if we, for example, we'll request Montreal between Christmas and New Year's every year. Typically, teams when they come in town, they go to both. Almost always, unless they're really close by, they go to both our arena and Tampa's arena in the same trip. So they'll come into Sunrise and then go up to Tampa, or go from Tampa to Sunrise and on. So in that ways, our schedules look pretty similar. At least our home schedules, maybe not our road schedules. Okay. Anything else? Anyone know why these go up and down and up?
Seems like renovations.
Yeah, it was renovations that year in Madison Square Garden. So, all right, let's look at the big picture now. So here's all 30 teams. I would say we see a lot of the same stuff. We see that winning probably matters. If we look at Boston, Chicago, LA, Nashville, Tampa, all these teams, their attendance went up as they got good. We see a lot of teams with flat attendance, like the Rangers have, right? It's all the Canadian teams: Calgary, Edmonton, Montreal,
Even Detroit.
Toronto.
Yeah, I mean a lot of the big market teams.
Vancouver.
Toronto, Vancouver.
Even Washington.
Someone said something about Winnipeg.
Yeah, Winnipeg.
Yeah, Winnipeg's flat. They were not flat here.
They were at Atlanta.
They were in Atlanta during this time right here, and then they went to Winnipeg and started constantly selling out.
What do you mean that they were originally in Atlanta? Oh, you mean like they actually changed location?
The team,
No,
yeah,
they-
the team was the Atlanta Thrashers, and
Okay.
then they became the Winnipeg Jets. Yeah.
Oh, okay.
I noticed that it's an upward trend in terms of the teams get good and they sell out, but if there's got to be teams that do badly, but they're not like spilling down, like they will have the opposite.
That doesn't happen as much, although you can see it here.
Mm-hmm.
Maybe a little bit here. I don't know.
Maybe with the, I don't know, is that Ottawa?
Ottawa, yeah.
Yeah,
Ottawa,
a little
yeah.
bit more so as well.
And St. Louis to some extent, but I think in general, certain attendance is going
Yeah.
up.
Yeah, and I think that's probably accurate because, I mean, hockey is becoming more popular. I mean, in more areas of the country and things like that. I mean, attendance can't grow in all the northern cities because it's already sellouts everywhere, at least in all the big cities. But in the South, I think hockey is growing in popularity. So, and plus, just population in general is going up. So you would expect attendance to go up. I think population's going up. I don't know about that actually, but I just assume it is. I guess another thing that we didn't point out was that's kind of interesting is, let's go back because it's easier to see. Just look at this year right here. Notice towards the left, there's lots of dots that reach down lower, but towards the right, almost everything is near capacity. I mean, that's happening because people early in the year don't care, and then they do care the closer to the playoffs that you get. And that's true in every sport. In the beginning of the season, there's just not as much interest. A couple months left in the season during the playoff race, people are checking standings every day, going to games more often, things like that. So let's, I think we talked about all these observations. So we wanted to build a model, like I mentioned. By the way, how am I on time right now?
Good.
Good? Like how much time left?
Probably 10 more minutes.
Okay. So let's talk about the model. So a lot of these predictors are things that we talked about because we kind of observed them already in the visualization that we looked at. So we got home team and away team. We're going to use those as predictors. Day of the week. We talked about Saturday versus Tuesday. Month. Holidays. You know, I listed a couple there. The days between Christmas and New Year's are big ones also. Whether or not it's a season opener, we considered season opener a holiday. Whether or not the two teams are in the same division or in the same conference. So are they division rivals or conference rivals? What's the points during the previous year for both the home and the away team? Because there's sort of a lag in how interested people are in a team. If you start winning, people don't immediately come. There's some sort of lag there. So we use points last year and also points this year. We included a couple interaction terms. One was a day-month interaction because we wanted to see if Sundays in the fall were different than Sundays in the spring because of NFL football. We did that. Let's skip that. Home team and month interaction. So are certain months better for certain teams in cities? So in particular for us, are the snowbird months better for us than they are for the average city? You know, for us, Tampa, Arizona, the snowbird months better. And so we basically did like a fancy type of regression. It wasn't exactly like a linear regression because we had all these these are all categorical variables with 30 factors. So we couldn't do a straight up linear regression and turn all those into 30 indicator variables. So we had to do something that was like, it was like a, sort of like a mixed effects model, basically, if you guys know what that is. But the interpretation of the results is the same. Impact that each of these variables has on the attendance, independent of all other variables. And so that's an important point, because we could just look at average attendance by day of the week or something like that. But that's a problem if teams tend to schedule big opponents on the weekend, or the league tends to schedule big matchups for the weekend, for like National Hockey Night in Canada, for example. If they purposely put the big rivalries on a Saturday, we're going to overstate the effect of having a game on a Saturday, because it's also affected by the opponents that are there. So we want to see what the impact each variable has, independent of all the other variables. And so here's the start of some of the results. So this is announced attendance. This is zero effect on attendance. This is positive effect, negative effect, and this is day of the week, Monday through Sunday. So Friday and Saturday are the biggest days. Monday, Tuesday, Wednesday are the worst days. Not too surprising, but here we've quantified it. I mean, this tells us, we knew this was going to be the result, right? We knew it was going to be the result, but we didn't have a way of quantifying that before. Like, we know Saturday's better, but how much better? How much better is it than a Tuesday? All other things staying equal. Well, we kind of know now. 1,100, 700, or 1,700. So about 1,700 difference between a Saturday and a Monday, Tuesday, Wednesday. All other things being equal. Here's month, October through April. So it's basically some sort of monotone increasing trend there over time. So people, as the season goes along, people are more interested in going to games. As the playoffs approach, people are more interested in going to games. Yeah.
Pardon, because I'm not too familiar with hockey, is there maybe some other factors other than just the general increasing, that maybe any insights that you may have had, say, about this effect of month on attendance, other than the fact that it's just progressing?
Part of it's football.
Okay.
Football being in the fall.
So it's a suppressing effect as
So
well.
that should be your competitor versus Lightning.
Why
How do you
six?
knock out the Marlins?
Yeah.
You know, how do you like?
Marlins is easy.
Yeah.
Maybe Heat.
Yeah, so there's more competition.
All we have to do is make LeBron go back to Cleveland, and then we're good. We solved that problem. Yeah, I don't know. I don't think we really compete with the Heat, actually. I was just joking with that, but it was kind of interesting, because I was like, moving down to Florida, I was like, oh, I should go to a Heat game, and then LeBron leaves, and I'm like, I don't want to go anymore. Yeah, I mean, so football is one thing. Snowbirds is another reason that month might have an effect, but this is league wide. So this is independent of the team, the home team. This is like an average effect across the whole league. Oh, and by the way, this is almost 2,000 difference between October and April. So if we just look at Tuesday in October versus a Saturday in March or April, well, we said 1,700 and 2,000. So that's 3,700 now. It's almost 4,000 people. Yeah.
So these numbers, actually, the max, maybe later you're gonna have more sellouts, so you're maybe missing like potential, because it's
that is
max.
true. Yeah. Yeah. So it is censored, like right censored or something like that. So yeah, you could be missing that. Yeah.
Do you think this is the snowbird effect, or is the playoff effect?
I think it's playoff effect, because this is not just us. This is for every team in the league. I shouldn't say for every team. I skipped that slide in the interest of time, but we got rid of the teams. We kept the teams that are small market teams like us. We got rid of all of the big New York Ranger type teams, big market teams where they just have flat attendance. It doesn't do any good to include them in the model anyway because their attendance is the same no matter what the predictors are. So I shouldn't say it was for every team, but there was like 13 teams that we included in the model. Here's the effect of away team on attendance. So 6 of the top 7 are the original 6 teams in the NHL. Detroit, New York, Boston, Chicago, Montreal, Toronto. The 7th is Pittsburgh, who has the most recognizable player in the game, Sidney Crosby. So, and they've won 3 cups in the last 7 years. They won 3 championships in the last 7 years. And then, 8th and 9th are 2 big market U.S. teams, Philly and Washington. But the difference between there's 1,200 and minus 700, so it's another 2,000 difference. Yep.
Pardon, on that last slide there, do you guys have yourself as one of the away team options there, or is that another Florida?
This is us, but this is we are the away team for some of the other 12 teams that are included in this model. Yeah.
Okay, got it.
Yeah. It's a little bit surprising that we're in the middle here and not towards the bottom. We'd think because they're newer teams that we wouldn't have as many people interested in going to our games outside of Florida or whatever. So I don't know the reason for that. It could be I haven't shown error bars here, so it could just be because of randomness or something that we're up here. So I've totally ignored error bars to this point. So that could be one reason, or maybe there's some other reason. I don't know. This is one of my favorite ones. Here's holiday. And in particular, here's every day around Christmas time where we thought there would be a huge spike in attendance. And I mean, this is December 29th, 3,000 on average, more people on that day, all other things being equal. So this is a big time where people, just because they have off, I guess, and they go to sporting events. What's that?
Kids are off school.
Yep.
Yeah.
Mm-hmm. Yep. Kids are off school. The holidays that have negative, kind of interesting. Halloween, Easter, these are times where people already have plans of doing something on that holiday. Either you're going trick-or-treating, or if you're in your early 20s, you're going downtown and getting drunk. Easter, maybe you're going to church, having Easter brunch in the afternoon, and then, not going to a hockey game. Season opener is, a big spike. President's Day, I don't know why, but President's Day was one of the bigger ones. But most of these holidays have some sort of pretty big effect. There's some sort of positive coefficient on these things.
Valentine's Day is interesting.
Yeah.
It even includes St. Patrick's.
Yeah. I think in a later version I did. I don't remember why it's not here. Maybe I just couldn't fit it or something.
Election Day is interesting as well. As people getting their mind off the topic at hand.
I think the first time that we did this, it wasn't the election year. It wasn't the 2016 election. This is 2000. But we did it in anticipation of that election, the presidential election. So that was interesting. And then here's the day, month interaction term. It's a whole big mess of stuff. But down here, these are so small that this could have just happened by chance. But I'm going to pretend that it's a real effect. But here's Sunday in the fall and Sunday in the spring. So we might guess that there is some sort of NFL on Sundays effect going on here. By the way, these coefficients are much smaller than the other ones because there's far fewer games that, for each of these combinations, there's far fewer data than there is for some of the other stuff that we have. And this model tends to shrink coefficients towards 0 when there's not a lot of data for that combination. So we're almost towards the end, I think. So so we use this model in part to come up with estimated revenue projections for each game. And here's how we did in the 16-17 season. These numbers are fake down here. I just did a linear transformation on both the X and the Y axis to hide the real numbers since I can't tell you what they are. This is our projected revenue, and this is our actual revenue for that game. And it's a pretty good correlation. I think, some of these, almost everything is close to this line. Some of these are way above, but we did a pretty decent job. And I should point out again that we only use data for these projections, for the attendance projections or the revenue projections, using only data known before tickets go on sale. So we're not using any ticket sales data at all. The only thing we're using is schedule-related data. Mm-hmm. And then the reason is because if we're using this for variable pricing, we need to determine our prices before tickets go on sale. Mm-hmm. So we can only use information known before tickets go on sale if we're going to do some sort of data analysis to help us with that. Of course, once tickets go on sale and we see how games are selling, we can update our predictions for revenue or attendance. But if we're, for the purposes of variable pricing, we have to use stuff that we know in the summer before tickets go on sale. So we came up with these numbers in the summer. Considering that, I think, it's pretty decent. How much time do I have?
10 more minutes.
Okay. Didn't you just say 10 more minutes, like 10 minutes ago? I'll show one more thing that's kind of interesting. So let's look at, so we mentioned once tickets go on sale, we can update our predictions. And let's see just evidence that might actually be useful. So in the red here, this is back when I used the default ggplot coloring. I kind of regret it now, but the red here is tickets sold. This is game. The red is tickets sold as of 60 days before the game. And I've sorted by the red. So this game had the most tickets sold 60 days out. This had the second most sold 60 days out. So it's sorted by the red. The blue is the additional tickets sold between 60 days before the game till the day of the game. So this whole bar is total tickets sold for that game. And so what this is showing is that, well, here's the order 60 days before the game. The final order is almost the same as that. It's almost decreasing here, almost exactly decreasing, except for a couple like weird outliers. This is an outlier, that's an outlier, that to some extent is an outlier. But pretty much the games where we had the most tickets sold 60 days before the game, those are the games that ended up having the most tickets sold once it was the day of the game. These outliers, we have really good explanations of why these are outliers. This one, if you're a hockey fan and you remember the 15-16 season, sometime in early in the season, Carey Price got injured and Montreal was very bad that year, the rest of the year. So this game in April, no one was really interested in seeing that game. Also, I haven't mentioned anything about price. All the stuff we've talked about assumes that you have reasonable prices, and I think we overpriced this game by a lot that year. So that's another reason there's fewer tickets sold. This is the biggest outlier. On the positive side, this is our season opener that year. We had a promotion on one day where we sold 4,000 tickets in one day. It was like $10 tickets for the game on 10/10, and they were on sale from like 10 p.m. to 10 a.m. to 10 p.m. or something. Some 10/10 promotion. But we ended up selling, because there was $10 tickets for the upper level, we ended up selling 4,000 tickets in a game. And so, that's why we way overshot our, what you might expect based on only looking 60 days before the game. Also, since that's our season opener, I'm not even sure that, I guess tickets probably just went on sale. Tickets weren't on sale for that long when you're talking about 60 days before the game, because 60 days before that would be August 10th. We probably went on sale August 1st or something like that with tickets. So There wasn't that much time to buy tickets anyway.
Actually, just a quick point about that last slide there. I don't know if you stated the goal. I guess the goal is to improve the overall profitability of the games. I was actually thinking about this earlier. Is there a lot of variable costs in the number of attendees in a game? Because otherwise the variable pricing would kind of tend towards just maximizing the number of attendance for any given game. Or is there a point where, obviously there's going to be some point, but is it very sensitive to the number of people that attend?
I would say the costs are probably far less than the revenue.
Okay.
So it would tend towards maximizing attendance. But it would,
to some degree,
it would tend towards maximizing revenue.
Right. Okay.
And if you have two different options, so it depends what you mean by revenue.
Right.
Because if you mean ticket revenue, that's probably not what you want to maximize. You probably want to maximize revenue from tickets, concessions, parking, and merchandise.
Right.
So if you have two different possible ticket prices and both lead to the same amount of revenue, you probably favor the one that's the lower ticket price because that means higher attendance, which means higher food,
Right.
beverage, merchandise, parking, revenue.
Thanks.
And I think maybe we should probably skip all this stuff. That you might recognize those from before. And I'll just show my contact information page again. And, oops. I'm totally lost. Okay, there. So, yeah, we'll just end there. I guess I didn't get to any of the hockey stuff, but I'm happy to talk with you about any of the hockey stuff. Maybe I'll give a teaser and just put one of those charts up here. We can talk about this if you're a hockey fan after this. So, yeah, this is shots. It's a heat map for shots. All right, maybe I'll just talk about it. Yeah. So, the larger the dot, the more shots that come from that area. The more red the dot, the higher the shooting percentage is from that area. So obviously, lots of shots come from here, and the percentage is high. Here, more shots come from here than here, but the shooting percentage is about the same. And so this is for the power play. In hockey, if you do something bad, you go to a penalty box for a couple minutes, and your team plays with only 4 players instead of 5. So this is for the power play. That's for the whole league. Here's one team on the power play. So that looks a little bit different. We've got hot spots here and a hot spot here. They must have a good goal scorer that stands over here a lot. And here's the same thing for a player. Here's a player's heat map, and this is just number of shots, not shooting percentage. Here's a player. Here's another player. They have very different heat maps, so you might be able to see, you might be able to say, like, looking at these heat maps, you can tell the tendencies of these players, basically.
How do you guys record that information?
That comes from the NHL. They have people recording the location of location of each shot on the ice. XY coordinates for every shot on the ice.
Is that a manual recording? Or
Yeah, I think they have like an iPad type thing. They're touching a picture of the ice where the shot came from, something like that.
Is that accurate?
I know that
It's
Good question.
like in soccer, I know Messi, like he got something in his shoes that basically they're tracking that based on the recording they're getting from his shoes.
So we don't have that yet, but there are companies working on it. So there's companies that do camera-based tracking, but it's non-intrusive right now. So part of the collective bargaining agreement is that you can't put tracking devices on players right now.
Maybe in the future they can put a chip in a puck.
Yeah, and there's companies that are working on that also. Actually, there's companies that have the technology and can do it. One of the problems in the past is that the pucks were very expensive. I think the cost is coming down now, but I don't know if you guys remember 20 years ago or something, Fox had the glowing puck.
Yes.
That was a chip in the puck. So they were doing it back then. And that same company still does it today, but the NHL so far isn't using it, but they're exploring options for Well, actually, they did it during the World Cup of Hockey, and they did it during the All-Star game, two of the All-Star games. They demoed some of this puck and player tracking technology. So they're investigating. They're interested in it. I think eventually we'll have it for all 31 teams and every game. Basketball, they have it for every game in the league. They have XY data for the players and XYZ data for the ball. I think 25 frames a second. So.
Do you worry about, because it's something I've thought about with that, is it almost become, when it's become too much data that you almost move back to, like, almost you're back to anecdote because the data is so huge and so complex you can almost find it anything. It's like, when I look at like every movement in a hockey game.
I've talked with, I know a bunch of basketball analysts in addition to the hockey analysts, and a lot of them will say, yeah, we really haven't figured out how to best use the tracking data yet.
Yeah.
I've seen some pretty good like research papers on the tracking data in basketball, and it seems really cool, and it seems like it'd be really useful, but then I talk with people who work for teams, and they're like, yeah, we haven't figured out the best way to use this yet, so maybe they're not doing the same things, or maybe...
Well, it's like
I don't know.
The research data I saw that was interesting was like you could find like certain people were really good at like rim protection different ways, but that was, it kind of told you what you knew.
Yeah.
In just a different way. It was like, we can show this a different way using this data that say Dwight Howard is really good at rim protection.
Yeah.
But it wasn't like something that you didn't already kind of see, and so it wasn't clear what the insight was.
To me, I think you already know the extreme cases.
Yeah.
If you watch baseball, you know Ichiro gets a lot of hits. You don't even have to look at his batting average. You just go to a game, and every time you go to a game, he has 2 hits. So you know the extreme cases. You know the stars. You probably know the people who are really bad at things. You know the extreme cases, but you're not really sure about the middle. And especially players who do everything kind of well, but they don't stand out in one area, and they're not like bad in one area. Yeah. These are the players that maybe you don't know about, and you also don't. I mean, you know your own players very well. You don't know the rest of the league as well. So in those cases, I think it's helpful to point out players that you might want to go watch more. For example, like I don't think you should use any of this stuff without watching games or watching film, either live or on tape. You know. So, but these advanced stats can help you determine which guys you might want to look at more often. Or
also, the difference between hockey and baseball is, the baseball is a sport which almost every play can be quantified. Mm-hmm. So you don't have to actually, watch a game to understand what's going on. But hockey, I think it's a totally different. You have to watch it.
Yeah, it's definitely different, and the ways you have to analyze the game are definitely different. Like you have to, if you're coming up with player metrics. You have to know who he's on the ice with, because if you're on the ice with Gretzky and Lemieux, you're probably going to be doing well no matter who you are. So you have to know who you're on the ice with. You have to know who your opponents typically are, because if you're a good player, you're probably the other coach is probably putting their best defenseman out against your best players. And other things like if you have a lot of face-offs in the offensive zone, you're more likely to score more and allow fewer goals. So things like that are all things you have to account for.
Yeah, that's why they have a plus and minus, but that doesn't tell you everything.
Yeah, it doesn't tell you everything. Yeah. So like one of the big stats is adjusted plus minus, and people have different versions of that. Some use goals, some use shots, but they're all somehow trying to account for teammates, opponents, and things like that. The other things that affect plus minus, but it shouldn't. We want to remove the effects of those things if we're coming up with a good player metric.
Do you ever collaborate with other pro sports teams in South Florida, like the Dolphins, Marlins, and Heat, on a project?
I would say not so much on this. Well, I talk with, I know the Dolphins analyst, for example, so we talk about things. We don't really do same projects because it's very different, but
maybe the Dolphins have been here for a while, and they have all this information regarding South Florida demographics, like which which food court items do you offer or something like that.
Yeah, I don't know if there's collaboration like that on the business side, because I think the Dolphins are probably like competitors of ours,
Yeah.
sort of.
Yeah, it could be a conflict of interest.
But so we could talk about maybe. I mean, I've talked about sports analytics stuff with the Dolphins analyst guy. I haven't talked with business. For other hockey teams, I mean, I know the analysts, but we can't really. I mean, most of us we know we're doing the same things because we all used to work together before we joined teams, but we don't work together now. But on the business side, there is a lot of sharing of ideas on the business side, because typically NHL teams are not competitors of one another unless you're one of the 3 New York teams or something like that. But like us in Tampa, I've talked with Tampa, I've talked with a handful of other teams. And there's even a league office that there's a department in the league office, business analytics department there, and they help all of the teams. So we talk with them also, and they actually facilitate the sharing of ideas amongst all the teams. So,
How was the transition between academia to business for you?
I mean, there's definitely some differences. In the beginning, it was. Well, I came in the summer, and it was just like a summer up at West Point. I was kind of working on the projects that I guess I got some. A couple folks in hockey operations kind of helped prioritize some of the projects, but a lot of it was just basically working on data analysis problems. But then, there's differences. There's no grading, so that's good. There's no teaching, which I kind of miss. But then there's, the problems that you work on, they have to be in some way business problems. That would be beneficial to the organization. They can't just be interesting problems that you kind of want to work on because it seems cool and it seems like a good use of this particular data analysis method. So you definitely have to be focused on the bottom line, which it's either some sort of like maximizing revenue type thing, or maximizing profit, or on the hockey side it might be maximizing goals or wins, or minimizing goals allowed, or something like that. So there's definitely like a focus on that kind of thing. When you're working in a math department at a university, the way you present things to people has to be different. So in a math department, you don't have to convince them that using data to help make decisions can be useful. But you might have to explain certain things about a sport to them. If you're working for a hockey team, you don't have to explain anything about the sport, but it might take a little bit more time to convince someone that using data can actually help you make a decision. I think there's like varying levels of acceptance of the use of data in an organization like that. And that could be for a variety of reasons. I mean, people everywhere in the world have been using just their intuition to make decisions for decades without using data, and they've done a pretty good job. So why should you use data? I mean, which is sort of somewhat legitimate. I mean, they've done pretty well. I mean, if you're good at what you do, you're gonna do pretty well just using intuition and experience and stuff like that. But but even in those cases, data can help get you an extra 5 or 10% of something. So convincing folks that that's the case can be challenging. So I would say that's one of the main differences between working for a team and academia.
But by not using data, you're still basing that intuition thing is all based on whim, and it's subject to your own skew.
For sure.
Or the whoever's
bias.
presenting your own bias, exactly.
Yeah.
So I'm always in support of using hard numbers to show that this is why this is a certain way.
And some people only want to use numbers to do that. So they only want to look at the numbers when the numbers agree with whatever they think. which
That's-
means the numbers are actually useless.
Yeah, but that's
how
what
you use them.
that's what you that's it, right?
Yeah.
But
The challenge is getting them to care.
that's what should happen most of the time. 80 or 90% of the time, a smart person's like intuition and gut should probably be the same as whatever the stats say. Because if not, then someone's doing something wrong probably. But the interesting times is when they don't match, and we've had interesting debates about certain players and stuff like that. When the scouts love them, the stats hate them, or vice versa. Stats love them and the scouts hate them. So, yeah. So.
I would imagine that, it's hard to, if you don't have a theory, it's hard to do good data analysis. And I would imagine like that part of it, the intuition is what generates the theories that guide the data now, at least would have guide good enough, scientific data.
Yeah, I mean, I think for sure those theories help you form your questions, help you form your problem statements when you're going to do some sort of data analysis problem. So, yeah, I mean, I think in order to do data analysis on any project, you have to know something. You have to be some sort of subject matter expert or be working with a subject matter expert in order to even formulate the appropriate questions.
The example of like helpful battle that you have to tackle with management.
I mean, I think it was just kind of what I said. I mean, it wasn't a specific example. I probably can't talk about like specific players or anything like that, but just a general idea of, if you have someone who's been really good at at assessing players by watching them for their whole career, versus doing that and also including data as part of that whole decision-making process. I think that was one of the challenge. I mean, that's one of the challenges for sure. And there's different people. I would say there's a bell curve of how interested people are in using data. Some people are really into it and want to use it all the time. In some cases, that's bad because they put too much emphasis on the data. They believe it too much, and it's like the cure-all for everything. Like if you hear about how people talk about AI and machine learning these days, I mean, it's like this panacea that's going to solve all the world's problems. So there's too much. What's that?
Blockchain is the other
Blockchain is the other one.
So there's that end of the bell curve, but then there's also the folks that are pretty resistant to it.
What tools do you guys use at Panthers? Which tools?
I almost exclusively use R. Some other folks on the business side use Tableau and SQL. A lot of Excel. I use Excel too. I would say those are the main tools. I mean, you could do R or Python. I just happen to learn R.
What's your favorite package in R? What's your toothbrush kind of thing?
What's that?
What's your toothbrush?
I guess I would say like I use ggplot all the time for these. I use Shiny all the time. I didn't show any web apps, but I've made a bunch of web apps where you can create interactive reports and just interactive visualizations. I guess those are my two favorite.
You ever played fantasy hockey or?
Yeah, that's how I started first analyzing hockey data back in like 2001. It was to help me win fantasy hockey leagues.
Do you have inside info for fantasy hockey?
Well, I don't really play anymore. Yeah.
What about a model for gambling?
If I didn't join a team 4 years ago, I would have considered doing that because at the time, at least, some of these things were actually legal to do online. I don't know what the law, like DraftKings and FanDuel, I think the laws have changed recently.
You
so I
can
don't
do
know.
I don't know if they're technically legal.
Yeah.
But this is running, right? This is law.
We're being recorded, so my answer is no, I don't. I've actually never. I'm really. Kidding aside, I haven't bet on sports. Partially because right now I work for a team, and that would be a bad idea. But I think I'm sure that you could make some. I don't know how much money you can make, but I'm sure you could do better than the field by using analytics. I mean, the people that are the big winners in FanDuel and DraftKings, and I don't know if it's baseball or football or whatever it is. They're making, I think I read 500,000 or 700,000 a year, and it's just someone doing a bunch of algorithms.
Do you have any recommendations in terms of like you know places to go to learn R or data science? Any books that you recommend? Anything that you will say, hey, if you're new to the field, like this is a must for you?
Yeah, I think there's a pretty good Coursera course, and it's done by Johns Hopkins professors. And I'm not saying because I'm biased because I went there. I was actually in a different department from them, although I do know them. But there's a data science, there's like a 10-course sequence on Coursera. It's free. If you want a certificate, I think you have to pay like $50 a course or something like that. I think that's pretty good. I think people have used like the Data Camp or something like that. It's got some free courses there. University of Miami Business Analytics program is pretty good.
What about books?
Books, one of my favorite books that if I were teaching a course at the undergrad level again, I would definitely teach a course in this book. It's Introduction to Statistical Learning with R. It's that yellow book.
From the Springer series.
Yeah. I think it's like Hasty, Tibshirani, Friedman, and someone else. It's the precursor to the Elements of Statistical Learning book. That's like the Bible of statistical learning, basically.
And they do the video course for free too.
Oh yeah? Okay.
On Stanford Lagunitas.
Oh, okay. All right. Yeah. That's a good book. I mean, I've gone through parts of Gelman's books. One is the multi-level hierarchical modeling book by Gelman and Hill, I think. That's a little bit more advanced. That's not really an intro book, probably, and then Gelman's Bayesian data analysis was a pretty good book. Yeah. But for someone starting out, I would say the Introduction to Statistical Learning in R or with R or whatever it is would be the book that I would go with. Yeah.
I have more of a business question. Like, what happens when your predictions are off?
My predictions are off, so I'm not sure I'd answer that question. Well, I mean, I think that you have to be honest up front that there's this point estimate for the prediction and then there's this error bound, and you have to be upfront about, hey, here's the prediction, but the error bounds are pretty high, or here's what the error bounds are, or something like that. So I have had that on the business side, where the attendance projections, folks would be always asking like, why was the prediction so low for this game, and stuff like that. And it's like, well, number one, we're making the prediction in the summer before tickets go on sale, and number two, I mean, there's still error bounds on these things. So, for example, like predicting what's going to happen the day of the game, I think that's something that we're not that good at yet. So, predicting how many tickets are going to be sold the day of the game, because there's been games where all of a sudden, we might have 300 tickets sold, that's it. And then all of a sudden, for some other game, we have like 1,500 tickets sold. And it seems to, I mean, there's some pattern to it, because if it's pouring outside, we're going to get fewer people that walk up to the box office window and buy a ticket right before the game. But there's part of that I don't think we really fully understand yet. So I think you have to be honest about what the model is saying. Like, here's the prediction, but it's not like we're going to get 15,000 people plus or minus 100 people. This is like plus or minus 1,000. Mm-hmm. And for the model that I mentioned here, where we update it over time, given 60 days before the game we have the ticket sales there, we can update the model based on that information. I think back 60 days before the game, the average error is 1,000, which means there's some that are off by 1,500 and some off by 500. 1,500 is a lot to be off by, but the average is 1,000 60 days before the game. A week before the game, it's something like 500 or 400. So that's pretty close. Mm-hmm. An average error at 400 is pretty close, but still there's going to be ones that are off by 1,000 and ones that are off by 2. Yeah, so I mean, I think you have to not be overconfident of what you do. One of my favorite quotes is that relates to data analysis, at least, is well, I guess it refers to like all areas of life. The difference between an amateur and a professional is that amateurs love everything that they do. I love that. So if you're going to be a real data analyst, you have to know the limitations of what you do. You know what the strengths and weaknesses are. You got to know how you might be able to improve those things over time. But you just have to be honest about the strengths and weaknesses of what you're doing.
Is there a copy of these slides online, or will that be?
I can put them online, I guess.
That'd be awesome.
We just can say that we can put in the Slack.
Yeah. Okay. There's a video also.
So this is our first time in this location, so we want to be respectful of time. Any other question, like 2 more questions before we go, or before we start? Anything else?
How do you like the business versus the sports?
I think they're both interesting. I think the sports side is probably more interesting, but there's still a lot of interesting business problems, and a lot of problems that were like totally new to me that I'd never thought about before. So I like interesting problems that I know nothing about, and like the attendance model, for example. I knew nothing about attendance before starting that, and I found it to be pretty interesting. I like making these visualizations with the maps. I think that stuff is pretty cool too. And we're building, the lead score models that we're working with the Miami students on right now. I think all those things are interesting. So there's different types of data. There's a variety of data going from on the business side. There's a variety of data on the hockey side. And the data between hockey and business is very different also. So I've kind of liked the variety of problems that I've been able to work on with the Panthers. So, I mean, I guess the hockey stuff, the sports stuff is probably a little more fun, just because it has to do with sports instead of like ticket prices or something. But data is interesting, no matter what it is. I don't know if that makes me sound like a nerd or something, but.
How many people are in your data science team, or you are the data science team?
On the business side, we have 6 people. Maybe 5. I guess it's 6 people. Yeah. On the hockey side, it was me and a few consultants. I was the full-time person, and then we had a few consultants also. So. I think that's probably about average for what teams do. I think for most teams, there's more people on the business side, it seems like, than the sports side, but I think that's changing also.
Do you guys have any physicists working for modeling?
No.
You need one?
Yeah. You should. Definitely, without a question.
What do you think you can improve the most in the Panthers data science?
I mean, I can tell you how we have improved things the most so far, and I would say that would be like ticketing and pricing decisions on the business side, and inventory management, basically, on the business side. So ticketing and pricing. We haven't gotten into marketing a whole lot, but I think there's potential there also for impact. And the lead scores thing, I think, has potential for impact also. On the hockey side, I mean, we weren't using data at all. Well, I shouldn't say at all, but we weren't doing a lot of data analysis before I got here. So just do the low-hanging fruit, and like whenever you're doing like step 0, that's a huge improvement over doing nothing. Step 0 and step 1 is better than doing nothing at all. So
Scale for drinks.
yeah.
Do you have any data science for recruitment, like for big league teams or something like that?
A couple of our consultants that I mentioned on the hockey side, they're focused primarily on amateur players who are eligible for the NHL draft. So you wouldn't get that, it doesn't get that young, so the focus is more on like 16, 17-year-olds. But yeah, so that's a challenging problem because number one, there's tons of leagues, and they're in North America and Europe primarily, and different, the leagues are there's different, the quality of the leagues vary fairly greatly. Plus you're just working with, you're trying to study the production of 16 and 17-year-olds, which can change a huge amount of time in like 1 year, and not just, they don't just physically change a lot, they can mentally change a lot, emotionally change a lot. So that's a pretty tough problem, but yeah, we do that.
When people come to you for advice in terms of data science, what's the advice that you provide students or aspiring data science people?
I mean, I think people ask me how can they get in to do data analysis in sports a lot. So maybe I'll answer that sort of. But actually it applies to data analysis in any field. The things that I think people, I guess people have seen like the movie Moneyball, and they see the glamorous side of data analysis. But I think people don't realize how much coding needs to be done to do data analysis. So I always tell people focus a lot on coding. I say like, this is what I look like during the day. Okay, I just stare at a screen and code for like 75% of my time. Maybe that's an exaggeration, but there's a lot of coding. Communication is really important, more important than you might think. So, and part of that communication, one of the best ways to do the communication is visualization. So I always say visualization is important. And the communication is important because you could have the best model of all time that is literally gives you predictions of 15,000 plus or minus 100. But if you can't communicate that to someone, the model is totally useless because you can't convince anyone that it's worth using. So the communication is really important. And then I think the last thing is it's not good enough to be a good data analyst or a good statistician or whatever. You have to have some sort of subject matter expertise on the thing that you're studying in order to ask the right questions, in order to come up with the best ways and the best predictors and the best variables to consider in order to answer those questions. So, if I didn't know hockey, I wouldn't be that good at analyzing hockey data, I don't think, because I wouldn't know what I should try to be accounting for. I wouldn't even know the questions to ask, other than how do you score the most goals. I guess that's probably 90% of the questions. But yeah, you need. Those are the three things that I tell a lot of students and other people who are wanting to get into data analysis or wanting to get into sports in particular.
What's the worst advice that you ever heard on data?
When I was in academia, someone said you shouldn't switch fields before you get tenure. I don't know that it applies to people in this room. I guess most people are not in academia, but I didn't like that advice, and I didn't believe it, and I switched fields immediately after I graduated from grad school to start focusing on data analysis and hockey, because what I was working on was theoretical math, and I enjoyed it, but I knew I wanted to do something more applied. And then I thought I really like sports, so I wanted to study sports, and hockey was my favorite sport. So I switched to that for that reason, and also it's nice to be able to study sports for the purposes of having undergraduate research projects, because undergraduate students are interested in studying sports more so than maybe like finance or something like that. Finance is probably a more lucrative profession, but for like an undergraduate student project, sports is more fun. So for all those reasons, for all those reasons and more, I switched fields, and so I ignored that advice that I didn't like, and I switched fields right then. I don't know if that really answers your question, but
Go with what interests you.
yeah.
You got it.
I guess, yeah, that's actually a good point. That's another thing that I tell students. You have to find some niche within the field of data science or data analysis that really interests you, because you're going to have to work hard at it, and it's much easier to work hard at something if you're really interested in it. So find something that you're interested in, work really hard at it, and find something you're interested in and have some sort of natural ability to do. Like, I could be interested in painting, but I don't really have any natural ability in that area, so I kind of shy away from that. My way of painting is creating visualizations.
Anything else, guys? Sure.
Thank you,
So,
Brian. That was great.
yeah, if you want to reach out to me, BMAC NHL is my LinkedIn, my Twitter, and my Gmail address. So feel free to reach out, ask any questions or whatever.
Alright guys, so thank you so much. Please network. This is a great community.